Hey, this is Mr. Ward, and this is PreAlgebra Exit Ticket 25.3 Video Key. And hey, look, there's the Andromeda Galaxy, and it's heading right for us. Don't worry, it'll take 4 to 5 billion years for the collision, and stars are so far apart, it's going to be pretty unusual for any to run into each other. But gravitational fields could affect things. But you have time to plan, because 4 to 5 billion years is kind of a long time for a human being. Now that galaxy is about 2.5 times 10 to the 6 light years away. It's probably about the same size as the Milky Way galaxy. Recent estimates you have revised its size down a little bit. We used to think it was a little bigger, but maybe 25 to 50% bigger. But currently, we're saying it's about the same mass as our galaxy, and that's the number we'll work with for today. So in the do now, we worked out that the mass of our galaxy, the Milky Way galaxy, a fairly redundant word since galaxy means milk, the Milky Way milk. Okay, at any rate, the mass of our galaxy is 2.98 times 10 to the 42nd kilograms, approximately. And the Andromeda galaxy is about the same and is 2.5 times 10 to the 6th light years away. Now, given that there are 9.461 times 10 to the 15th meters in every single one of those 2.5 times 10 to the 6th light years, what is the gravitational force between the Milky Way and Andromeda galaxies? So we're going to use the Newton's law of gravitation equation here. So we're going to put in G. So let's start organizing our information. We know G is 6.67 times 10 to the negative 11th. And then we're going to multiply that times the mass of our galaxy, 2.98 times 10 to the 42nd kilograms, and the mass of the Andromeda galaxy, which is the same, so we may as well just square that. And that's going to be divided by the distance between them, which is 2.5 times 10 to the 6th light years. And then we have to multiply that times how many meters there are in a light year, 9.461 times 10 to the 15th meters per light year. And that whole product needs to get squared because it's distance squared in the denominator. That R stands for radial distance. That's the distance between the centers of two objects. Okay. Now, let's start grouping things. We'll start off by grouping the coefficients. So 6.67, and that's going to be times 2.98, which is going to be squared. And that's all going to be divided by, in parentheses, 2.5 times 9.461, and that's also squared. And now we'll deal with the coefficient. That's the coefficients. Now we'll organize the power. So we've got 10 to the negative 11 times 10 to the 42nd. And I'm going to put that in parentheses because that's also squared because we're using the same mass for both galaxies. And that's going to be divided by, in parentheses, 10 to the 6th times 10 to the 15th, and that's all squared. Whew, that's a lot. So let's start organizing things further. Let's take our coefficients and find out what they come out to. Looks like we've got, let me see if this organized the way I wanted it to. Did. So 0.1058. So I'm going to call that 0. And there's a 7. So I'll call that 0.1059. I will round it to there. So 0.1059 for our coefficient. So obviously we'll have to adjust. And then let's start organizing all this. So that will end up being 10 to the negative 11 minus, okay, plus, what am I saying? Because it's added, plus Let me move myself back. Let's put this, let's go ahead. So we got negative 11 plus 42 times 2. So 2 times 42. Okay. And then we'll be subtracting 2 times 6 plus 15. Okay, so that's all of that. And we can start simplifying that. I'm going to leave that there, 0.1059. And over here, let's see, we've got 10 to the, okay, negative 11 plus 2 times 42 is 84, minus 2 times 6 plus 15 is going to be 21. We can take that one more step, 0.1059. We're not ready to deal with you yet. 10 to the, okay, negative 11 plus 84 is going to be 73. And that's going to be minus 2 times 21, which is 42. 1059, still not ready for you. Okay, now we got to do 10 to the 73 minus 42. And we end up with 31. A pretty big number. So we got to adjust. We got to make that 1.059. And then the 10 to the 31st has to become 10 times smaller. So 10, because 1.01059 became 10 times bigger. So that's 10 to the 30th newtons. That is a lot of newtons. That is humongous. So that looks to me like it's going to be in the neighborhood of 2.5, or yeah, about 2.3 times 10 to the 29th pounds. But a galaxy takes a lot of force to move, so it's going to need that kind of force to move it. So there you have it. That is the number of newtons between the Milky Way galaxy and the Andromeda galaxy. Now we're going to simplify this one. So I've got x's and y's, and I've got a 4 in the denominator. So that 4 is going to just sit there because it's not really doing anything. So I'm going to have a 1 over 4. We can just leave that there. We're going to have an x to the 4 minus negative 1. And we'll have a y to the negative 3 minus 3. We can simplify further. 1/4. X to the 4 minus negative 1 is going to be x to the 5th. And y to the negative 3 minus 3 is going to be y to the negative 6th. And so we'll end up with an x to the 5th in the numerator. So x to the 5th. And we'll leave the 4 in the denominator, and that's going to be times y to the 6th. You could have said x to the 5th, y to the negative 6th, all over 4. That would work as well. But it is better to have, well, it's more, I don't know if it's better, it's conventional to use only positive exponents when simplifying. Either one is fine by me, however. Now, here we have a couple optional challenges, and I will go ahead and quickly walk through those. So here's a coefficient of 2 in there that's being cubed, so I'm going to deal with that separately, 2 cubed. And then let's deal with the x's and the y's separately. So the x's, I've got an x to the negative 3 and an x to the negative 2, and that's times going to be cubed, so that'll be times 3. So I'm going to say 3 times negative 3 minus 2. And then I also have to subtract 1 for that x in the denominator, so minus 1. So that'll get me my exponent for x. I should actually use the little symbol for an exponent. And then over here I've got y. So inside here I've got some y's, but I'm going to start with the times 3, and I'll times 3 and then there's going to be 2 plus 2, and then minus negative 3. I can just start simplifying. So 2 to the 3rd is 8. And then I have x to the 3 times all that business in there. So negative 3 minus 2 minus 1, that's going to be negative 6. And then the y, I'll leave that 3 there, and I'll simplify what's inside the parentheses. 2 plus 2 will be 4, minus negative 3 will be 7. And the 8, we're not ready for you. X to the negative 18th power, because that's 3 times negative 6. And y to the 21st power. And I'll put it all together. I'll get 8y to the 21st over x to the 18th. Or you might have said 8x to the negative 18th. And then y to the 21st. That would work as well, though the first version is the preferred method by convention. Okay, one more optional challenge for us. We've got all these a's, we got a negative 2, some b's, so let's deal with the 2 first. So that's going to be 2, negative 2 power, which I'll deal with in a second. We've got a's, and we got b's. So let's start off by raising it to the negative 2 times something. That's also raised to the negative 2 times something. And the times something is going to be all these powers inside here. So I've got an a to the second, nothing else. Oh, there's a 3. I forgot about that. I'll come back to that as well. Actually, I'll deal with that now. There's a 3 to the negative second as well. Okay, so we've got 2 minus 1 minus 3. Okay, and then up here we've got, for b's, we got negative 2 plus negative 2, so I'll call it just minus 2. Then minus 2 again, and then minus 1. And when I take care of this, I forgot that there was 1 down here, so we'll say minus 1. Okay, so, all right, so that is what we've got. So let's start sorting things out. So, I did a boo-boo there. Okay, so I'll deal with that later. I seem to have set this in short answer form. So I'm going to go ahead and sort all these things out like this. So 2 to the negative 2 minus 1 is going to be 2 to the negative 3. And 3 to the negative 2, I got 3 to the negative 2. I'll put that there. I'm just going to put an equal sign here so I don't lose track of things. And then I've got an a to the negative 2 times all that stuff inside there. 2 minus 1 minus 3. So 2 minus 1 is going to be 1. 1 minus 3 is negative 2. Okay, and then b, oops, I can get back over there. So I've got b to the negative 2 times all this business in here. Negative 2 minus 2 is negative 4, minus another 2, negative 6, and then another minus 1 is negative 7. And we can keep sorting that out. I've got 2 to the negative third, which is going to be 1 over 8. So that's 1 over 2 to the third. And that's going to be 3 to the second. Oh, I did it again. Now I've got 3 to the second, so that's a 9. Okay, and then I've got, I'll put a star in there so we know we're multiplying. And then I've got an a to the negative 2 times negative 2, so that's a to the fourth. I've got a b to the negative 2 times negative 7, so that's b to the 14th. Okay, so we're almost there. So I've got a 1/8 times a 9, so that's going to be 9 in the numerator. A to the fourth will also be in the numerator, 9a to the fourth. b to the 14th will also be in the numerator. And I'll leave a little space between those so it's a little easier to see them. And that's all going to be over 8. And that's your answer. I hope that helped.